All right. Thanks a lot. Welcome back to week 5. So, this week we're going to talk about the impacts of AI starting from this week. So, we're going to talk about AI's material footprint, then we're going to talk about AI and jobs, then we're going to talk about AI and media, and just a bunch of things like that in the coming weeks. So, today we're going to talk about like a very ongoing debate about AI's material footprint. And I think this is a good transition from weeks 3 and 4 because it translates the sort of compute story and the evolution of that into real world, right, into the physical world, and how, like, we think about, okay, there's this technology that is implemented, but there's a lot of costs that go with that technology that make it, like, practical in real world kind of issues that come up with that. So that's what we're going to discuss today. And I mean, yeah, we'll again, like in the spirit of this class, the idea is to have an open mind and think about this as a holistic, issue that has, all kinds of viewpoints. Like, we come at it from our own bias, but then we think about it, from different angles. So here, we talk about things like data centers, chips, buildings, substations, water, capital expenditure, local politics, and things like that. And again, like, the idea, I'll talk about this in the next slide a bit, but just want to say this again is, this is meant to be like a place where we come with an open mind and then think about the pros and cons and of different arguments that are made. It doesn't mean that I subscribe to a certain type of thinking, or just because I am talking about a certain thing does not mean that I believe in that thing. I think as part of our training, what we should be we should also learn is this ability to think and reason from what the other side, what a side that we may not be thinking about is thinking about. Okay, and that is very true for a topic like this, right? Like, so AI and its impact on the environment, be it in terms of like electricity, water, carbon footprint, expenditure spent, like, all of these are, you might have an opinion on them, right? And especially for a thing like this, which is very current and which is progressing very fast, things like, okay, will AI be a success or a failure? Is it a bubble or a revolution? Are data centers worth the investment or not? Will the environmental impacts of AI be manageable, or are they going to be severe? Right? Like, these kinds of questions are really hard to have a clear answer to, and we all come with our own priors, right? Like, so for I mean, I'll talk about my priors in a second, but a lot of the answers to these is we don't know, like, we don't know yet. And I think that's a really good point to start with. Like, so we don't necessarily take a position here. We think about, okay, what is this going to do, what is this going to do, and then come to a decision. So this is about having these sorts of multiple things in your mind, right? It's not just two things, pro or con, but having these multiple angles and inspecting the evidence and notice the conclusion in with respect to the priors that you want to reach, right? Like, and here again, like, I have my own priors, my own prior, and my own bias in this thinking is that AI is mostly good. Like, there's going to be huge benefits that come from AI. So when I read about headlines like, okay, AI is a bubble, or AI is environmentally horrible, my first instinct is to think of reasons why this argument might be wrong, right? Like, that's this confirmation bias. You want, your mind prefers not to have kinds of ways of thinking that challenge your current beliefs, and these beliefs might be formed because of various reasons, right? Like, I might be personally benefiting a lot from AI, so I don't want AI to fail, for instance, right? Like, so uh, that's not a rational argument. Like, it's not like, if AI fails, I'm going to lose something, right? So that's my thinking on this. But the idea here is, okay, I might have that prior, but I'm aware of my prior being that, biased in that sense. And my the way I think about this, and part of the course is like broadening our thinking to realize our priors and then say, oh yeah, I support AI development, but what is the other side saying? Like, what is the side that opposes AI development? What is their argument? Like, is there value in that argument? Like, what are what are things that I have not been able to think about and things like that. Uh, so this is something that we need to really critically develop. I mean, okay, AI impacts is not as charged politically as yet as other things. Like for instance, I don't know, politics, left-right politics in the U.S. super charged, right? Like so, if I say I am right-leaning supporter or a Trump supporter or whatever supporter, like that's much more like people have a much more visceral kind of view of like, or you form opinions based on these kind of opinions. But at least AI is not as polarized as it is now. Like, but it will become more polarized as we'll see throughout this lecture. But the point here is that part of this course is for us to develop this skill of thinking about what the other side is thinking about and then trying to reason about like what they might be right about, what we might be right about, and things like that. And in many cases, there's no perfect right or wrong, as we'll see in this lecture throughout. Like a lot of these questions are unresolved. Like so, there is no clear correct answer because we don't know to a large extent, is AI a bubble, is AI a revolution? It's not very clear. And the 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 bad thing about a lot of these sorts of polarized issues is this sort of binarization, like saying, okay, AI is a bubble or a revolution, right? Like so, saying these sorts of binary, okay, it's either this or that. It's neither. Like it's usually most of the times it's both or it's either, right? Like so, things like that are very common, and like that's I think another thing to learn about is thinking about not thinking in this sorts of binary black and white kind of thinking. So we've seen this before in terms of bubble or revolution with previous generation technologies like railroads, for instance, in the 1800s there's this huge railway mania. So I was just in upstate New York, and there we're learning about the history of rail in the middle of nowhere in upstate New York, and they were talking about how in the 1800s all these huge railway barons like were fighting to and racing to lay the most amount of track and all of that stuff. Anyway, so it's I was just there yesterday, so I just got reminded of this. But there was this speculation of, okay, you build the rail and then people come invest in your business. So there was no, I mean, there was no technology like the railway that connected like large swaths of land across the U.S. Right, like, and it was a huge investment. Like the people were spending like tens of billions of dollars at that time. So to do this sort of with the assumption that once you have this rail, you will have commerce, business, and things like that, which is very similar to what it is right now, right? Like so we are spending a lot of money and effort in developing these data centers, electricity for the data center, water for the data centers, all of that stuff, hundreds of billions of dollars, with the assumption that this technology will play out. And it is, again, like, is this, in the case of railroads, like, obviously railroads have played out and became a huge success, like overall, like in the development, the economic development, the connectivity, and like connecting the country and all of that stuff. Railroads definitely played a big role, but it was not as immediate. Like if you read the history of railroads. The same with electrification. Like again, in the early 1900s, there was this huge electrification boom. Like again, yeah, it's similar in terms of like these really rich people, rich business people, trying to lay as much electricity infrastructure as possible with the assumption that it will bring in like some sort of economic rewards. And it was not immediate. Like this obviously electricity is a huge economic positive for the country, for the world in general, but they did not, the benefits were not immediate. Like it's not obviously because if your life was not built on top of electrification, right? Like you did not have the machines that use the electricity, so it was like a chicken and egg problem. So it took a long time for the benefits of electrification to come in, but the infrastructure still changed everything. It's the same for dot-com fiber. So this is maybe something that I've seen at least in my lifetime is in the 1990s. There's a lot of investment in dot-com, like in the internet. Late 90s, early 2000s, a lot of money was spent in laying down fiber to be able to reach the entire country, connect the country with high-speed internet and things like that. And a lot of firms that actually spent this money went then bust. There was a dot-com crash. A lot of companies went bankrupt, things like that. But still, like the fiber that was laid during that time, during that uh, bubble in quotes, because it was a bubble at that time, but it really led to this internet revolution. We're now watching YouTube and gigabytes of video and all of this stuff like easily because of the infrastructure that was laid at that time. So obviously, I mean, there is a flaw here in comparing these different technologies. It doesn't mean that, okay, because, railways or electricity or dot-com fiber had the sort of boom and bust or the bubble and revolution effect. It doesn't mean that AI will have of that same effect. Like we cannot be sure. But what I meant to say was this sort of binarization, right? Like, so you cannot just say, okay, is this technology going to be, is it a bubble or is it a revolution? Like you really cannot answer these. And, if you go back in time, there's a lot of evidence for this that, nobody could tell. Like, even now, if you open, any of these opinion pages of many of these mainstream news sites, there's always these, oh yeah, AI is revolutionary or AI is a bubble, things like that. Like, so it's usually not the right binary to argue for or against because it's not a binary. Okay, so the next thing we want to talk about is the transition from compute becoming infrastructure. So we talked a lot about the advances in technology, in like these development of these new architectures, and the way these are trained on large amounts of data that provide this sort of intelligent models and RL and all of that stuff, right? But that eventually comes to reality where all of these things like the scaling laws, the frontier models, the agents, is they all require compute to get better. But this compute is not an abstract thing, right? It means there needs to be this sort of physical presence of chips, GPUs, networking, buildings, power to power those data centers, substations to deliver the power from the source to that, cooling systems, land construction crews, a bunch of things like this. And then, so this week we asked this question of what does the scaling story require from the physical world, right? Like, so if you want to really keep building these sort of massive models that just take a lot of data and produce this sort of intelligence out of it, uh, what does that require? Like, and who bears the cost? Like, I think that's a very important part of this. Like, at least as this is I mean, this is something that's often invisible, right? Like, so when we are watching our YouTube, whatever, Instagram Reels or TikToks or YouTube Shorts, things like that, like our videos, we don't really know that there's a huge infrastructure that is lying underneath that someone has spent like hundreds of billions of dollars building, right? Like, but because that has happened in the past. So, but this thing is happening right now, and this is a transformational technology. It's so huge. So we are living this experience, and it's something that we are now seeing and becomes more and more part of our daily life, our daily discussion, and we'll come to it like because it's also something that is individually impacting all of us. And this is also impacting all of us because the scale is very different, right? Like so, uh, what we've seen until now is nowhere close to what we are going to see or what is happening with the build out of these data centers and the infrastructure for AI. So if you take a look at your traditional data centers, like traditional data centers that serve your YouTube usage or like whatever internet usage, this was tens of megawatts. It has a lot of these cloud applications, storage, like all your data, your photos, all of these being stored and served to you. Required these data centers, which are huge already. Tens of megawatts is a large amount of power. But then we moved to this sort of hyperscaler era. This is something that we mentioned last week a bit, right? Like this is, in the hundreds of megawatts with large cloud regions, with high utilization, custom hardware, dedicated energy procurement, things like that. But now we are going to move to this sort of frontier AI specific loads, which are unprecedented. Like, I mean, we haven't seen something like this before. These are like this gigawatt scale data centers, which are built around like model training, inference, accelerators, speed of deployment, things like that. Like, so the future that is being envisioned for this is very different from what we currently are even used to, right? Like, so our current loads are just we have this ChatGPT model that is like whatever a big frontier AI model that is trained, that requires some sort of investment. So maybe a hyperscaler, like a large data center sitting somewhere, could do this. But because of the change to this sort of test time compute that we saw last time, a lot of the compute is happening at inference time rather than at the training time. So that requires these massive, massive data centers that still are able to process these AI loads, which are not your normal browsing loads, your normal internet browsing loads. So there's some inference happening at test time, like meaning, I'm using my application and then it's thinking on its own, like it has some sort of AI on its own. And so that requires a lot of inference, which is just going to be much, much, much bigger than your training uh, requirements that are already like in the hundreds of megawatts in terms of power usage. So this is the future that we're anticipating, where AI is this sort of layer on top of everything that we do. Like, so there's going to be on-device AI. So your phone, like Apple Intelligence, something that we haven't seen yet, but it's going to come. Like where there's some AI models running on your phone locally. There's always going to be some AI running on top of everything that we do. That is, intelligently customizing, intelligently doing something that we're not used to right now. But it's a new way of compute, a new way of thinking, and we don't know what that is yet. But this is the future that we're building towards. That requires these sorts of gigawatt scale data centers that are being developed now. And these gigawatt scale data centers are just arriving, and we haven't seen or done anything like this in terms of infrastructure, into the compute power, and all of this in the past. And this build out is like massive, like really, really massive. Like, so this is, if you put it on a plot, like it looks like this. A 1 gigawatt campus is roughly like a power plant scale. So if you have a huge nuclear power plant, like, so that's 1 gigawatt of power is produced by that. And so there's this Meta Prometheus data center that is being built that uses around a gigawatt of energy. So that's so much energy that it is just unbelievable in terms of the what we are used to. So this is here, it's on log scale. So these are not comparable even. So 30 megawatts and then 10 gigawatts are like 300, 3 gigawatts. So that's like 100x, probably like a 300x difference between this and this, right? Like, so this is a legacy data center that is used to serve your internet loads. And the Stargate, which is this OpenAI Oracle initiative that is being planned right now. I think part of Stargate will come into operation this year, later this year. So it's already operational. Like part of it is probably going to be operational very soon. So that's around 10 gigawatts of power usage. And these are just unbelievably large uses, like uh, we have not seen an investment like this, compute requirements like this, and the downstream effects of this. And so here the the bottleneck is no longer chips. Like, so one small thing before this, I mean, I have a bunch of examples here. Meta has a bunch of them. Like this Hyperion is like this really, really massive, like Manhattan's sized campus, which is like a data center the size of Manhattan. Just imagine the size of that. And XAI has one in Missouri. A bunch of like these have already been commissioned, and like for them, they every company like Microsoft has one, Amazon has one, Oracle, OpenAI has one, Meta, the Tesla slash XAI has one. Like all the big companies have these sorts of investments made, and we see the capex, like the expenditure being spent on this, is in like close to $1 trillion. $1 trillion private investment is just unbelievable. Like, but this is the scale of investment that's being made here, and so the bottleneck is no longer just chips, right? Like, so here, one of the things in the past maybe 2 years or so, one of the main bottlenecks we had was that NVIDIA, which is just the main provider of GPUs for training all of these, has been bottlenecked because of supply constraints. Like, so they're not able to produce as many chips as required, like, and they're rationing a lot. Like, if you as a personal computer user, like I wanted to buy a gaming GPU, that's not available anymore, so on, right? Like, so constrained by chips. But now we are entering a stage where the bottleneck is no longer chips. Like, it's not that NVIDIA is not able to produce these GPUs. Obviously, there is that bottleneck, and that will be resolved maybe in the next 1 or 2 years. We'll have enough capacity that all these companies in the supply chain, like ASML or TSMC, like some of these chip designers or chip fabricators, chip manufacturers, all of these, the supply chain is being built up for them, like to scale this up to produce the right amount of chips. But the main bottleneck now will become more of power, right? Which is the if you want again, like, this is unimaginable scale for what we have done previously, right? Like, so there was no data center that was gigawatt scale previously. Now we have a gigawatt scale. We have thinking of 10 gigawatt scale, which is just probably like hundreds of thousands of homes worth of energy. Like, so there's a big city, the amount of energy that a big city uses, that's the amount of energy requirement. We're asking for a single data center campus, and there's going to be multiple of those. Right, like that will require the generation, transmission, substations, interconnection queues, meaning like the sort of balancing of loads. So sometimes you're using solar, and then the night there's no solar, so you have to replace that with some other source. All of these stuff that requires long-term energy contracts, because obviously building a nuclear power plant or a solar farm or a wind farm, like, these are not cheap. Like, they require like decades of investment, and like all these laying off these wires and the substations, managing the peak power. Like, suddenly, in the summer, now it's hot everywhere, everyone is using their AC, and then the data center requires 10 gigawatts of power, so it requires a lot of investments. There's also the speed angle to it, like, right? Like, if this was something that we would do over the next 2 decades, maybe it would be fine. But all these companies want it to be done in the next 2 years or 3 years, right? Like, so this has been a 5 year window and a race to do this, which is just not, again, something that we've done in the past. And so recently there was this, I don't remember what it's called, Colossus or something. XAI had this huge data center in Missouri or Kansas, or anyway, so in one of those states where they just did not have power and water, so they had done all sorts of like really weird and hacky ways of like generating power with gas turbines on site, and like getting water from a river nearby, like a bunch of things like that, like, which has never been done, right? And that creates all sorts of issues, but also new innovation in terms of modular designs, gas turbines. Tesla is now working on producing these turbines themselves because there's some bottlenecks in that supply chain and so on. And then there's also this physical aspect of it, like where these data centers are set up, like local land, noise, water usage, tax incentives, community approval. Like they become much more of a reality. We'll get back to this in a second. Like this is going to be a local political issue pretty soon. And this is why AI becomes this sort of politically visible infrastructure. Like we have never, obviously Facebook has been building these data centers for making their like Facebook widely accessible or whatever you make sure that your reels come to you without a lag or things like that. The internet infrastructure has always been built over the last 20, 30, 40 years, but you've never seen that yourself, right? Like, so it's happening somewhere and just get it on your phone and you don't see it. But now we are all realizing this because of these three aspects. So there's this power aspect, the speed, and the place. And the amount of money being spent on this is just infrastructure scale, meaning it's just we don't usually, again, private equity spending this kinds of money is unprecedented. So the big five hyperscalers, which is like the ones that I mentioned, Oracle, OpenAI. Again, maybe I might be wrong in exactly naming the five, but it's some of these like Meta, Amazon, Microsoft, Oracle. Maybe there's XAI, OpenAI, some of these, Anthropic. All of these, they're spending roughly around $600 billion to $1 trillion of capital expenditure. $1 trillion, or like even $600 billion of private capital is just so much money, right? And a lot of this is just AI infrastructure. So it's for the servers, GPUs, data centers, networking, power, and so on. And like this is how the spending has been over the last few years. So it was already started in 2022 with 162 billion, but now in 2026 the estimated spend is around 600 billion. Again, like if you add these up, like in 2022, 2025, 2026 itself, it's close to $1 trillion of money spent on this. And a lot of these are a bet on future demand, right? Like this is this is where this sort of discussion of bubble or revolution really comes into play. And so the build out makes sense if there are going to be paying demand from customers, right? Like, so, right now we're all being, at least I'm paying like $100 to OpenAI, $100 to Anthropic, and so on, right? Like, so this is new spending for me. That was not there 2 years ago, maybe. But is this going to be is there going to be this sort of demand from enterprises, from more customers, from scientific computing, all of these kinds of things? Is there going to be demand or not? We don't know, but this is anticipating there will be a demand. Like we're building a lot of this infrastructure. So if the demand arrives slowly, then this is because they're really compressing the timelines on the build up, right? Like, so they're trying to build all of this in like this 5-year time horizon from 2022 to 2027. So there's going to be a lot of overbuilt, underused infrastructure, which will lead to this sort of standard capacity, debt defaults, depreciation, things like that. So the material footprint question, which is the buildup, and the bubble question are connected. And the environmental cost is easier to justify if the social and economic value is real, right? Like, so that's the ultimate goal, the ultimate answer to this question of like, is it worth the investment or not? Like, it's not very clear because yeah, there is this anticipation that there's going to be this huge demand in terms of economic value, which is that we're all using AI to be more productive and whatever, earn more money or have more free time, do things that are enjoyable, that we are able to spend money on, the money on. But also like there'll be some sort of social benefits that come with it, which is things like, okay, cure to cancer, like medical innovations. There's scientific breakthroughs in various other fields that unlock, whatever free energy or things like that. Like so, there might be these sorts of things that are being anticipated, which we don't know if they're going to happen or not. So let's now look at each of these on its own. Like we look at electricity, we look at uh, carbon emissions, look at water usage and things like that. And again, I started with saying that this is a really open topic, like meaning there's no conclusive answer to this works or this does not work, because we don't know the answer to them. This is happening right now, so we don't know. I mean, 2 years, like if we spending hundreds of billions of dollars is worth it or not, but and whether the benefits that come with that are going to outweigh the negatives that these cause. Okay, so in terms of electricity demand, like this is going to be a huge burden on our electricity grid, right? Like so, this is from the International Energy Agency (IEA), which says that the global data center electricity use was 415 terawatt hours in 2024, but it could be more than double by 2030, right? Like so, it's massive, double. I mean, these things usually, grow slowly by maybe 5-10% a year, but doubling in 5 years is like a really huge jump, like in terms of the amount of usage. And this Lawrence Berkeley National Laboratory says out of that, 176 terawatts, terawatt hours was data centers, which is around 4% of US electricity, right? Like, so this is a lot of it is being spent for we're using it for data centers. So this the amount of electricity used per query can be very small. So there's a lot of estimates on trying to estimate if you search once on Google or compare that to how much ChatGPT uses or either in terms of the energy. This is again there's competing numbers here. We cannot be really sure what numbers to believe in, because there's a lot of fluff and spin on both sides of the discussion. Like people who claim that AI is dangerous maybe take the maximum number. The companies take the minimum number. So there's this sort of huge variance, like orders of magnitude variance. So we cannot be really sure, but roughly, I think the agreed upon number is that Gemini text prompt is 0.24 watt hours, which is negligible per query, compared to various other things that we do, eating meat, for instance, is extremely energy intensive. Like it's compared to that, it's as much, or driving a car is much more energy intensive compared to these. But there's a lot of heterogeneity here. Like I said, these average numbers always mask out things like video generation or image generation. So image generation is again has increased a lot. We'll see this in week 8 or so, and the consequences of that. What that is: image, video, audio generation. So those are probably 100 times more expensive per query than text generation. And again, your thinking models are much more expensive because they have this sort of test time compute, which is compute per query, right? So previous generation of ChatGPT models would just have a pre-trained model that just replies to you, but now you are doing for every query you have to do some sort of inference, which uses more power, so it's much more expensive, and so on, right? So you cannot put a single number and say, okay, per query this is the charge. And that's where you get these sorts of wide range of variance. So, there's a study from people at CMU, which is heavily contested by these companies, which says, okay, you use 3 watt hours per query of ChatGPT, but the official numbers from Google are around 0.24, which is similar to in scale to the amount you would use for a regular Google search, for instance. And some independent studies by these kind of companies like APOC, they also report something around this range. So it's on individual level, it's very small. This is negligible. So it's not something that I don't know. At least I'm not thinking of, oh, should I Google search this or not? It's something that I use without thinking about. The companies want us to think that these numbers per query for Gemini or ChatGPT is supposedly around the same number, the same scale. But like I said, like there's a lot of difference here in terms of the. So this is per query. Even for text, it doesn't include like all these sort of pre-training. It also doesn't include the type of models. If you're using a very simple model, it might be this. Otherwise, it might be different. If you're using it for image or video generation, it might be much more, and so on. So these numbers are really hard to have a single number and say, okay, I will use, or like I will make a decision on whether I'll use AI or not based on this number. Uh, they also have this sort of localized component to this in terms of electricity use. So if we say, okay, 4.4% of our energy is for data centers, okay, less than 5% is not bad, like for something that hundreds of millions of Americans are using every day, and providing a lot of economic value or not. Like we'll see this in the next week's lesson on AI and its impact on jobs and so on. But the main problem here is that the data centers are not spread across the country. So it's not like 4.4% of all regions in the country are using this electricity. So basically, what happens is the data centers are concentrated in a very small portion of the states. I think 10 states account for more than 80% of the data centers. So Northern Virginia, which has like a majority, like by a large amount, like they have hundreds, like 700 or so data centers in that small region in Northern Virginia, which is called the data center capital of the world. In general, even before, there were a lot of these Loudoun County and all these in Northern Virginia because of their location. And close to the population centers in the Northeast, all of this stuff. Like there were a lot of data centers there. There are more being built there now. Parts of Texas, Oregon, Arizona, Georgia, and emerging Midwestern sites like this thing in Missouri. I think the Meta data center is also somewhere in the Midwestern sites. So there they face a lot of these constraints, much more. Like so, this 4.4% again hides that sort of regionalization. Like so, for instance, Virginia or Texas, some of these places, they face this burden much more than compare other places which are not in this list, right? So they're like finding the power, delivering it like through these interconnection queues, transmission capacity, substations, backup generation, who pays for upgrades. All of these will have effects on electricity prices for end customers. Like so, people like you and me, we are seeing our electricity costs go up in part because of this, and it's also the way the system is set up. I'll get back to this. I have a paper on this, and I'll talk a bit about that. I'll also refer you to the paper about how this is a complex thing. But even if a data center is being set up in Virginia, I'm in New Jersey, and I still have to pay for that because of the way the electricity is procured, distributed, and then who pays for all of this is a very complex system. So yeah, that is a complex thing. We'll get back to that in a second. So it's not, you should not ask this question of how much AI uses electricity globally, because yeah, you'll always get these sorts of very small numbers that can be made to look like AI usage of electricity is a minor thing, right? Like, but the problem is not that the overall usage of electricity, like if it's 4%, I think it'll go up to 7% or something by 2030. But that number is still a very small number. I mean, people will say, oh yeah, if you take aluminum production or like whatever, like steel production, it'll take like much more amount of electricity for the type of economic output it produces compared to AI. But okay, that might be true, but the problem is just this sort of concentration because these data centers are very concentrated. The effects are local, like so you will feel these effects much more in these specific parts of the country, and that is a problem. So the second thing we talk about after electricity is water use. Again, water is also super local. It's much more quieter than power. Like Water is also a finite resource. I mean, same like electricity, but electricity can spin up demand, but water is not. AI uses water directly for cooling and indirectly through electricity generation. And again, like this is where like the reporting may or may not be biased. So some studies they only cite water for cooling, which is much more efficient actually. Um, but if you also take into account the electricity generation process that is used for AI, then it might be even harder. And again, like the published estimates for water usage. Again, this is the study from the CMU people on use of water for GPT-3 is millions of liters, projects billions of cubic meters of AI water withdrawn by 2027. Again, like this is contested. Firstly, the amount of water used, but also it's not put in context. Like if I tell you, yeah, AI uses hundreds of billions or hundreds of millions of liters of water. Sure, like that sounds like a really large amount. And if I'm an AI doomer, like I don't like AI, I would say, oh yeah, that's a waste of water. But there's a case to be made there. Like if you take again, like I've seen this on Twitter. I don't know if it's right or not, but if you take all these golf courses in the US, apparently they use like I don't know 2% of water used across the country, right? Like, so just watering the golf courses. I don't know if this number is correct, but yeah, it's somewhat, I would believe it. Like, so, we use water a lot. Like, so if you look at farming in California, for instance, you grow all these almonds, pistachios, they use like, I don't know, 1,000 times more water than a normal crop would. So that is like, again, like we use water like that inefficiently in many, many other places. So there's the case that, AI water usage is not that bad. And yeah, so there is, definitely the fact is that there is, AI data centers use water both for the cooling, but also for the energy generation part of the process. And uh, the other big factor that not mentioned here is it needs to be fresh water, like so it cannot be seawater, impure water. So this is water that you would use in your house, so it has to be purified before it's sent to these data centers. So it has to be fresh water, and there's lots of stuff like water evaporation because it's used in this cooling. It has to be fresh cooled water. So there's a lot of energy usage in there, a lot of wastage of water in that process as well. But it's overall like the process. Like again, like maybe we'll get to that in the next slide. Is that this is also a very complex thing because it's only used for cooling. It's return to its source, right? Like, so it's only used for cooling. So once you get the water passed through for cooling, there's some amount which is evaporated, but otherwise it's returned to its source. And this is useful for other purposes. Like let's say if you are in a location where you can use hot water, like so the water is used for cooling, so it gets hot after it cools the data centers. So you could reuse it for heating purposes, right? Like if you have the infrastructure to do that, but if you don't have that, it's a different story. Again, like the amount of water lost for evaporation is another factor, but that's maybe, again, I don't have a number on that, but that's not the majority of water that is lost. So it's a cycle, like so it's not completely that you're just throwing water at it and you don't get anything out of it. Like so, you just pass through the data center for cooling and you get hot water back, which is returned to the source. So you could reuse it later, but it has to be sent in through this sort of purified waste and so on. But there's a lot of innovation happening there that will use like normal water and reusing the water and all of that stuff. So this is where also the place dominates the ethics. So it should, are they using a lot of water? Maybe overall, like it's given the cyclic nature of because you can reuse this water. It's not adding impurities to the water. All of that stuff. So it may be not an ethical question that much than a place question. Like so, a liter in a water-rich region is not the same as, again, like a lot of these desert, Abu Dhabi and UAE are setting up these huge data centers. Already they're getting water from desalination, which is a hugely energy intensive uh, process. And so if you're spending like, again, like billions of liters of water that you get from desalination to cool these data centers, that's actually a really wastage in terms of use of water, I would say. So in terms of design, you could also have air cooling, evaporative cooling, liquid cooling, recycled water, closed loop systems. They create different types of trade-offs. Again, like per prompt, water use is also a huge distraction. It doesn't matter, like, if per prompt, like it uses, I mean, I've seen again this sort of huge variation, like the amount of electricity per query. That's a meaningless number. Is it like, I don't know, I've seen like these many number of liters to these many number of milliliters. So there's again huge orders of magnitude differences, but it doesn't matter. Like if it's in Abu Dhabi, where it's a desert and you're getting this water that you would have used it for otherwise for other more productive purposes, that's a bad use. If you're in whatever water rich middle America where there's lots of water, then maybe it doesn't matter. So it's very, it doesn't matter these per prompt numbers. And AI water usage is real. Again, like I said, it uses a lot of water for sure, and can be locally serious, but these sorts of prompt level statistics are the wrong way to reason about it. Okay, so we've looked at electricity and water. Now let's look at carbon. Carbon, I mean, this is a, there's no two sides here. Carbon, obviously, we are messing up the planet with this sudden surge in these data centers that are all now being mostly powered by unclean sources. So we don't have the renewable infrastructure to power this sudden massive surge in electricity requirements. So a lot of the power that we are getting from these are gas turbines or coal. So most of it is very unclean, pollutes the environment. So there's a lot of carbon that's being thrown into the environment because of these sudden build out. So maybe over the because of this investment and sudden requirement, we will transition to more cleaner sources, but that will take like 10, 20 years. So, we might be in, I mean, there's a resurgence of like nuclear power in the US. We are building nuclear power plants again after a long time. And that's a really good thing. Nuclear is the most cleanest energy source. And maybe we'll also invest a lot in like cleaner energy sources. So in maybe 10, 20 years, this might pay off. But right now, this is really a bad thing for carbon. Like we're putting out a lot of carbon. And these big tech climate pledges, so Google, Microsoft, both of them had this sort of climate pledges of like being climate neutral, like whatever carbon neutral they call it, like the amount of energy they produce versus consume. They want to balance it out at some point. Like, but now I think they are just reneging these pledges because they're not able to keep up anymore. Uh, so things like you've seen this sort of very massive increase over the last 5 years, like 40%, 30% increase in terms of the amount of carbon emissions generated by these companies. And again, like yeah, there's lots of these accounting hacks that happen in the way you read it. Like so, if you look at these accounting stories, there is uh, location-based accounting, which looks at the physical grid, emit, where the actual data center ran, right? Like what the energy required to run this data center in that location, what was the carbon footprint of that. But then there's a lot of these tricks that the companies play, which is they buy like some sort of carbon credits, which are, okay, you plant a huge chunk of forest in the Amazon, and there's a lot of scams in that. Like there's a very, very good investigative reporting in that space where these companies have this sort of carbon pledges where they say, okay, we're going to plant these many acres of forest, and that counters for our carbon usage here. And I think now they've even given up on that. But so it's again, like you cannot trust these numbers. Overall, I think here you can make a very clear case that carbon footprint wise, we are really messing up the planet. Obviously, again, there's this sort of longer term benefits that might come in, which we are not very sure of. Like, firstly, efficiency in terms of energy usage. So these data centers will become more energy efficient because of this pressure on these companies to be more carbon neutral, but also efficiency in terms of the switch to more cleaner sources like nuclear or solar, wind, and so on. There's also other factors in this chain. Like, it's not just running the data center, but the concrete needed to build these Manhattan-sized data center campuses, steel, chips, backup generation, construction. They spit out a lot of carbon as well. Like, so those are again not included in any of these estimates usually that are put out by these companies. Okay, the final problem is the sort of local politics, which is the encompassing problem. We see this more and more now from AI. I mean, I've never heard of problems with whatever video, data center being built by Meta to serve me Reels or something, like, because that was a small scale operation. But now we are seeing a lot of this because it puts together all of these problems that we put together. Right, they're not only reacting to carbon. You see a lot of land use, water use, transmission lines, tax incentives, and uncertainty on who pays for the grid upgrades. Again, like, this is a good thing that this has become a political issue, because now we have the companies to be held accountable for paying up for their usage, right? Like, a lot of these contracts are made, contracts for a data center coming to town are made in a very opaque fashion, like, and there are lots of tax incentives provided with the assumption that this will bring up like some sort of economic benefits, jobs to the local community, or economic uh, uh, benefits to the community, like tax incentives, like the data center companies pay lots of taxes and things like that. So again, like here, it's not very clear about what these benefits will be, like, meaning, okay, we know for sure that these data centers, they don't create a lot of jobs. So for the size of the operations that they run, these data centers are really lean. So they might create some sort of temporary construction jobs, all these electricity upgrades, all of these will create some jobs in the short run, maybe 2 to 5 years. But after that, these data centers are super lean operations. So they don't employ a huge data center will employ probably 100 people or so. So it's not a big operation that is beneficial for the community. It may bring in some sort of tax revenue, but I'm not sure if that is beneficial for that is compensatory enough for all the negatives that come with that data center, which is water use, land use, noise, pollution, all of these kinds of problems. The other thing is also the grid upgrades. Like, who's going to pay for that? Like, that's a huge problem. Like, we'll talk a bit about like what some studies show about that. Like, our data centers increasing our electricity prices because these grid upgrades are happening for everyone. Like, our grid, particularly in the US, is very old. Like, we really desperately need upgrades to the grid, but it hasn't happened in the last 40, 50 years. So we are really in need for a grid upgrade. And these data centers coming to town is a good reason why, why there might be some of this sort of upgrade in our infrastructure. So in that sense, this is a long-term investment. So if the grid is upgraded, like, we have new wires, new poles, new technology, new substations that make it more efficient, then we can benefit from it. We can all benefit from it, and that has some sort of cost to it. But it's not all our responsibility. If a data center comes outside of town and laying the lines and the power generation capacity to that, obviously I don't want to pay as a customer for a data center that is not going to potentially benefit me. But we might also have to pay for that. But it's not very clear, like, which part of it is going to benefit me in the next 20 years, which part of it is, am I paying to subsidize the data center coming to town? And there's a lot of, like, again, political activity around this. It's going to become much more politicized in the next few years. Probably even later this year in the midterm, AI is going to be a big big issue. Companies, they emphasize the sort of jobs, tax-based digital infrastructure, and clean energy procurement. Again, like a lot of these are real to a certain extent. Like again, like I said, jobs can be misleading because a lot of these are temporary jobs. Residents will ask whether the benefits and burdens are matched. Things like permanent jobs, there are few large resource claims, like they're taking a lot of water, land, energy, and tax benefits and so on. And these opaque utility deals can create distrust. And so this AI footprint is not just an environmental topic, it's also this issue of governance, transparency, and cost allocation. And like this is something that we will be seeing again, like I said, more and more politicized and more becoming a political issue going forward, and which will potentially, hopefully, come to a good conclusion. Unlike, I don't know, climate change, for instance, is a political issue which is for the bad, right? Like climate, we cannot agree upon that this is a bad thing, even though it is a bad thing. I really hope this AI data centers being politicized will be for the good, meaning it'll end up in an equilibrium where the companies will bear more of the responsibility rather than skipping out like their responsibility. I hope like this politicization of AI will lead to an outcome like that rather than this sort of AI is bad versus AI is good as split between these two political camps, which is what usually happens in our political system. Okay, so just to quickly summarize this sort of environmental section, like water, electricity, carbon footprint, and political usage, political local impacts. These three things can hold true at once. So first is per unit, these effects might be very small, and there might be efficiency improvements that make it even cheaper. Like, so your efficiency estimates in 2023 may not even be valuable or reasonable today. So this is one that is true. This is correct. Like per unit effects are very small. So I probably don't or shouldn't care about using ChatGPT once or twice or 10 times, like I don't think of using Google search, right? Like, so it's may not be that bad. But the aggregate is undeniably large, like especially at this scale where hundreds of millions of people are using this billions of times. This is going to be a huge impact. And again, especially because of this sort of large variance that includes a lot of cost. So if you're using it majorly for image generation or video generation or for training these models, things like that, they are really big chunks of that massively blow up this usage, so that we don't know what portion of these loads serve those. And then the other is this sort of local concentration. A lot of these effects, electricity, water, carbon footprint, all of these are the answer to is this good or bad depends on where they are being deployed, right? Like a lot of these fall on specific communities, and where there are differences in like watersheds or rate structures and existing grid and infrastructure and so on. So the sort of AI is destroying the planet and AI's footprint is trivial are really, again, like this is very straw man argument. Like it's a very high level argument that may not really make a lot of sense. The serious answer depends on the sort of unit, place, and counterfactual. Like so, I think this is something that we need to take away from this. Okay. Uh, um, yeah, I know this is been a very long lecture, already an hour into this, but I still have a bunch of slides. So hopefully, yeah. Anyway, hopefully this is beneficial and interesting. So let's keep going. So will it pay back? Like, we spent half a trillion, more than half a trillion this year, right? Like just this year, we're spending half a trillion into this. Is this going to be beneficial? So there's this sort of Sequoia Capital, which is like a very big venture capital firm. They estimate like that's around 600 billion, working backwards from this chip spending, the spending on chip infrastructure, that supply chain, data center costs, cloud margins, and so this industry requires a huge AI revenue to justify this build out, and this capital expenditure as it rises, the implicit revenue assumptions also rise. Like, so if you're spending 200 billion, you're expecting 300 billion as output. Like, but if you're spending 600 billion, you want 700, a billion, trillion, whatever amounts that justify that spending. And the hidden bet is that AI demand will not just be impressive, but it will be also monetizable at this scale. Like, so if you want a new technology that comes out and has this sort of impact that can generate $1 trillion, I think that is a really hard ask. And you can make this sort of bear and bull case for this. Bear as in like a doubtful, like, okay, AI is not going to succeed. The capital running ahead of its value. Which is that this, there's a lot of studies that make this case, like this AI is a bubble and all of that stuff. There's this MIT's 2025 Gen AI Divide report, which argues that most of the enterprise pilots have not produced measurable impact in terms of productivity, and infrastructure also deprecates quickly, right? Like the GPUs have an age limit. Like, you cannot, obviously, the new generations of these GPUs are being generated every few years. And so, GPUs from 5 years ago are no longer the best. They also have an age shelf life. You would not use GPUs from, I don't know, 10 years ago because they're either too slow or are not able to keep up with the pace of the software being developed, because that is also something that, like we saw last week, is also being developed really fast. And there's also a lot of circular financing. There's a lot of reporting, really interesting reporting on this. So Oracle funds NVIDIA, which funds OpenAI, which funds Oracle. There's a bunch of things like that, which are circular financing, where suppliers finance buyers, and so it's really complicated, which is a very good case that this is a bubble. And the bear case is plausible. Again, like, a lot of really very well thoughtful people make this sort of bear case, because for that to happen, it doesn't mean that AI is useless, right? Like, and that's the thing that people are confused about, is that people think that if you make the bear case that AI is a bubble, it means that AI is useless. It's not necessarily the case. So this is a very important point, because what is being said here is just that the bear case is just that the investment is too much, too fast, and too early, right? Like, so if there is no demand that comes in immediately for these hundreds of billions of dollars to be worth it, then you will really have a bear case where this is going to be a huge bust, right? Like a bubble that is going to create a lot of debt and bankruptcies and things like that. The bull case is that the diffusion takes time. So these task level gains are real in many settings. Again, at least personally, I feel this. I believe this is that a lot of these tasks, like writing, customer support, coding assistance, translation, research workflows, have already shown meaningful productivity gains. And this is part of the evidence that this is going to work out. Like, and we've already seen like some of these. For instance, Anthropic has doubled their revenues from 1 year ago, and in the last 3 months or so, they've doubled again. Like, so it's really a massive growth story because of some of their products, like Cloud Code, and that really shows that there is demand for this. And they've shown that it could be in the I think they have like 100 billion in revenue now, or some massive number like that, like, which is just unprecedented. So this might be happening. Like, so it need not be the case that this is not going to happen. There might be there might be a future where this might happen. Uh, Enterprise integration is slow for every general purpose technology, and because this requires a lot of workflows, management, measurement, and complementary investments in training people and things like that. So we'll see about this in the next lecture on AI and labor. And the infrastructure may outclass, right? Like, so if you're building this huge physical infrastructure, the electricity, the power lines, the data centers, the chips, and everything, So even if people take some time to get used to this and start using this and getting meaningful productive outcomes, this might not be the worst case. Like we saw with railroads and fiber, which show that financial bubbles can leave useful networks behind. And the bull case does not necessarily need every current project to win. It just needs enough demand to grow into the capacity. So what we're building, if we can find the capacity for that, find the demand for that capacity, then I think we should be good. Okay, so I think now is a good time to just pause. Like, I mean, it's been a really intense, past hour or so. Like, what we want to do now is just pause for a moment and like think about what your original priors were and whether some of these factors that I laid out really will change your mind or not. Like, so if you lean bullish, meaning you support AI and like you want it to succeed, like what evidence over the next year would make you doubt the build out? If you lean bearish, like what evidence would make you believe that the investment will become justified? Like, so I think a really important part of this class in general as well for us is to be able to think about these cases based on evidence that we can collect, that we have, like we saw in this class. And so, think about not just about vibes, right? Like, it's not that, oh, I read this piece here, or my cousin told me this, or whatever. Like, no, not vibes, but evidence, right? What kind of data does this have? And your beliefs should always be updatable, like when new data arrives. Like, so, we should not, especially in issues like this, which are ongoing, where there's no clear outcome, whether this is going to be good or bad, bullish or bearish, we cannot be sure. Okay, so let me quickly just give you one case study. I mean, this I included at the end to show like some of my ongoing work on the connection between AI data centers and electricity prices. How this is, again, it seems like a very simple connection, right? Like, so the story here is about this. This is also something that we are all personally uh, um, 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 experiencing. So people do not, if I say, okay, it takes like 400 terawatt hours, like we don't know what that is. But if we see the monthly bills that we receive, electricity bills, we've seen this sort of increase over the years. And now we've been hearing that, oh yeah, there's a lot of these data centers being built up. Like, so people will make that sort of connection, right? The mechanism is that a large new electricity load for these data centers will require a lot of generation, transmission capacity, and distribution upgrades. And that, I've seen my electricity bills go up. So that's the cause why I want this. Why I'm paying a lot more in electricity bills, right? So the data centers are being built and the electricity bills are rising. So as a human mind, like we want to make these sorts of correlations and say, okay, that is causing this. But the answer to this is not that easy. Like, we have some work. This is not just my work. There's other work in this space as well. This is a much more complex task to make this sort of causation, like that data centers are causing this because of various reasons. So one is the grid infrastructure is very complex. Like, it's not as trivial as this. There's a lot of like built-in mechanisms to prevent this sort of localization. There's this sort of ways to distribute the costs and all of that stuff, which make it very complex. Which are yeah, it's very complex. So it's basically there is these public utility commissions which are regulated by states that have some sort of discussion with the local communities in order to set these prices and to increase the prices. Then there's a lot of these market design mediate pass-through mechanisms, a bunch of things like that. And a bill is also a bundle, like, so there's usually 3 or 4 of these components in that bill, which is generation, transmission, distribution, And capacity. Capacity is one that we don't think of usually, which is the most expensive, or like not most expensive, but the most volatile one, which is usually every grid will keep a portion of the bill for the peak time. So, in peak summer, like there's going to be like a week where it's extremely hot or it's extremely cold in the winter, where you need a lot of energy and electricity. So if you don't budget for that, like your grid will fail. Like if everyone switches on their AC at that time, it's going to be a huge strain on the grid. There's a lot of energy required. So the providers will go and purchase a lot of power that, or at least promises for delivering that power for at this extreme peak, which is going to be very, very expensive. And that costs like around 10-20% of your bill. Anyway, so this is too much information, but so bill is not just that, okay, there's a transmission line being laid and that costs you something. That cost is distributed and regulated to a certain extent. The generation cost is regulated. The capacity costs happen in the market, so there's an auction, but it's not completely, it's not full. A big portion of your bill, like I said, is 10% of your bill or something. Uh, and a lot of these trends have offline reasons why they increased, right? Like, so the trends may predate data center build up. Like, so for instance, this is data from the US Census, which shows the average bill across all states in the US. It has just massively increased in 2021, and this is because of various reasons, including bad timing, bad policy, green policies, all of these like really complex stuff. Like, it's not just one thing, but we've seen like roughly like $10 to $15 on average increase in electricity bills in 2021, 2022. Like, and this is Russia war, like energy market impacts, a bunch of things like that. So the bills usually go up over time, like at this 5 to 10% rate. But suddenly there was this jump in 2021, and this has nothing to do with AI, right? Like, it was already paying more, even pre-AI, the massive AI data center buildup. So that's one, right? So this is something that we don't necessarily think of. We usually correlate that with data centers, but there's this pre-AI bump, which is very evident, which is very large as well. That has happened. The other is also that the data centers are not randomly assigned. So data centers are usually set up in areas where obviously these companies want them to be cheap and manageable, economically viable, and so on. So the data centers are located in areas where the power is cheap, abundant, and so it's you cannot make these sorts of comparisons. Again, this is data from Texas, but these trends hold almost across all states, which is that trends across the average power rate per month in zip codes with a data center, without a data center, are going to be different. And without a data center is always going to be lower, not because if you have a data center, the power charges are lower. It's just because data centers are set up in areas where the power is usually cheaper, right? Like, so these are in remote areas or in areas with abundant power or with access to your power plant more easily, or things like that. So it's not that trivial to say, okay, if a data center comes down, my electricity bills will go up. That's not easy. So there's a lot of mixed evidence. It's not settled. Again, like, maybe I mean the video is getting too long. So it's a mixed. It's a regional market. So there's mechanisms built in to manage these sorts of costs. And there are many other factors that play a role in this. And my own study, I can point you to that in a second, like, shows that these effects are like the data center effects, causal effects are like minimal. You have at most like around $2 increase in electricity prices. There's a lot of caveats in this. This is effects through 2024, where these hyperscaler buildups have not happened yet, and so on. Yeah, I mean, this is something we have to be very careful with. So no effect does not mean no evidence, does not mean no effect. We don't have the evidence yet, but does not mean there's no effect. The careful conclusion is narrow. We don't have local residential evidence with available data. And this does not prove that data centers are harmless. The largest AI campuses, the data centers, are being built up now. and the cost of these will arrive like in 1 year from now or so. So we may be too early in measuring this. And again, like this is a very good exercise to think past correlation, right? Like so, again, we usually quickly try to make this sort of connections, a human as a human, but this may not always be true. And so I have a paper on this that is linked here. Like if you want, you can go to this link, pause the video. It's a website that I created also with AI that kind of explains the data we collected and the effects that we observed, and a very detailed paper, which is like, I don't know, 80 pages or so. It contains a bunch of analysis that backs up this evidence. Okay, so now let me conclude. Again, like I mean, this is another exercise that you could do, which is thinking about you can use the data from that interactive visualization on this website and try to make this case. So yeah, think about that. Okay, so just to quickly summarize now, you for any AI footprint claim, you can have four lenses. So one is the sort of per unit versus aggregate. So small per unit query cost and huge total demand. These both can be true. Then there is the sort of local and national effects. So these manageable national averages can hide stress on localized grids or watersheds. Then there's correlation versus causation. So we see these all the time. We have these huge two trends moving together. It does not mean the evidence of one causing the other. Also, evidence does not exist mean that it did not happen. Like we just don't have evidence. So that's important as well. The other is this sort of bubble versus infrastructure angle to this. So we have this sort of financial overbuild can coexist with durable technology change, right? Like so, and we've seen examples of this with the dot-com fiber or with railways or electrification and so on. Okay, the final slide. Uh, what we know, what we don't is this build out is unprecedented. What we don't know is how much demand will materialize and when. In terms of electricity, this is again huge increases in electricity uses. What we don't know is to what extent this will be in 2030. What effects is it going to be on the grid in terms of local grids, efficiency offsets? Is it going to really, okay, it will impact the modernization of the grid, but is it going to offset the huge increases in electricity use or not? In terms of water, it's again, we know it's a huge local issue. We don't know in terms of like the efficiency gains of there, like what are the indirect effects of your use of water in electricity generation, watershed specific burdens, reuse of water, we don't know those. In terms of carbon, again, like we know that this is going to mess up our carbon footprint pledges at least. What we don't know is in the long run how this benefits. Like maybe AI will lead to positive outcomes in terms of climate change, like where we are generating, like creating new technologies that can carbon capture or whatever, maybe, and then in terms of bills, we know that there is plausible pressure in some markets. We don't know if there's like some general local residential pass-through or not. Okay, yeah, that's it. Yeah, sorry that the video was a bit long, but hopefully, you've taken. I mean, there's a very complex arguments to be made here, and I tried as much as possible to break it down and make this argument. Like so, hopefully, this will come through and you like it. Like, let me know if you have any questions. Again, here's my email. Thank you.